Welcome, curious minds, to another deep dive. Today, we're really plunging in, tackling some of the universe's biggest and, let's face it, most stubborn mysteries.
Absolutely. Things that keep physicists up at night.
Exactly. We're talking dark matter, that invisible stuff.
Yeah.
Then there's dark energy pushing everything apart faster and faster. And, the fundamental nature of space-time itself, even maybe faster than light travel.
Concepts that, have been real sticking points for decades.
But what if? What if there's a completely different way to look at all this? A unifying theory?
Well, that's exactly what we're exploring today. We're venturing into a really extraordinary theoretical framework. It's called the Big Emergence theory, or BT for short.
BP. Okay.
And at its core, there's this foundational structure, a bit of a mouthful, I admit, the Hyperfractal Hyperspace Coherent Resonance framework.
Whoa. Okay, let's shorten that. HHHCR.
HHHCR, yes.
Yeah.
Much better. It's essentially a model, a new lens, suggesting that a lot of what we think is fundamental gravity, mass dimensions, isn't. It actually emerges from, deeper unseen layers of reality.
Emerges. Okay. And our mission today, for you listening, is to take all this complex stuff, the research, the notes, everything we've gathered, and break it down.
Yeah, make it digestible. Give you the key insights.
Think of it like a shortcut to understanding this, pretty revolutionary view of the universe. We'll dig into how these hidden layers and resonance patterns might explain everything. Gravity, consciousness, maybe.
And potentially lead to technologies that sound like pure science fiction right now. Mind-bending stuff.
We want to focus on those aha moments, the surprising connections, what it could actually mean for us. It's about seeing the universe maybe in a totally new light.
Connecting the dots in ways we haven't before.
All right, let's dive in. Part one, let's start right at the foundation.
Yeah.
What exactly is this big emergence theory? What's the core idea?
Okay, so the core idea of BT is proposing this unified picture where fundamental things, gravity, mass, inertia, even the dimensions we experience, aren't just static givens.
Not just baked into the cake from the start.
Exactly. They are emergent properties. They arise. They come into being from deeper interactions within a more complex underlying system.
Okay, emergent. Can you give us a simple analogy? Something every day.
Sure. Think about wetness. A single water molecule isn't wet, right? But get billions of them interacting, flowing together, and the property of wetness emerges. It's a collective behavior.
Or like a traffic jam. No single car is the jam.
Perfect example. It emerges from how the cars interact. BT says fundamental physics works like that. Gravity isn't just there, it emerges. Mass emerges.
And this helps avoid some dead ends in traditional physics.
Yeah.
Like singularities.
Precisely. Classical models, like in general relativity, predict infinite density at the center of black holes, or at the Big Bang. The math just breaks down. It predicts infinities, which physically don't make much sense.
A sign that the theory is incomplete, maybe.
That's how many see it. HHHCR suggests these aren't actual physical infinities or dead ends. They're more like transition points. Gateways, almost.
Gateways.
Where? To higher orders of complexity. The coherent structure of spacetime shifts, reorganizes itself at a deeper level within the hyperfractal structure instead of collapsing into an impossible infinite point.
So the universe just finds a new way to organize itself, avoids the crunch.
In essence, yes. The underlying structure keeps evolving. No true physical infinities needed.
And HHHCR, that hyperfractal hyperspace coherent resonance framework, that's the engine making BT work. The blueprint.
That's it, exactly. It's described as the unified model for the big emergence. It provides the rules, the mechanisms for how these properties emerge, how dimensions evolve, how it's all connected. It's the core physics.
Okay, so what are the key principles here? I'm really curious about this hyperfractal universe idea. What does that mean for space-time?
It's fundamental. It basically says space-time isn't smooth and static like, Einstein's rubber sheet analogy.
Which is how we usually picture it, right? A 4D background.
Right. Instead, HHHCR posits it's continuously dynamic. It's evolving through dimensional resonance and fractal expansion.
Fractal expansion. Like those intricate Mandelbrot patterns.
Kind of like that, yeah. Imagine self-similar patterns repeating within patterns, but in, potentially infinite dimensions, extending far beyond our familiar 3 of space and 1 of time.
Whoa. So our 4D universe is just one layer, one expression of this deeper fractal reality.
Exactly. Just one emergent configuration, like a shadow projected from a much richer, higher dimensional object. And it's not static. It's a continuous, coherent process, constantly being shaped.
Mind-bending. Okay. And the other principles, coherence and resonance, what role do they play?
These are the absolute unifiers, the heartbeat of the system. Coherence is about things being synchronized, maintaining a stable relationship, like perfectly tuned oscillators or waves moving together.
In sync. Got it.
And resonance is about vibrating at specific frequencies, how one system strongly responds to the vibrations of another. Think of the classic example, a singer shattering a glass with just the right note. Bet says everything, from quantum particles to galaxy clusters, is governed by coherence and resonance. These principles maintain stability, allow complexity to emerge, and stop the universe dissolving into, well, chaos.
So the universe isn't just happening on a stage, it is the stage, and it's constantly tuning itself, organizing itself through these principles.
That's a great way to put it, a self-organizing system.
Now, self-organizing can sometimes make people think of, well, consciousness or intelligence behind it. Is that what B implies?
Good question. No, not necessarily. In this context, self-organizing refers strictly to physical principles. It's about how complex patterns naturally emerge from simpler, repeated interactions governed by resonance and coherence.
Like snowflakes forming intricate patterns just from water and temperature. No guiding hand needed.
Exactly. It's natural emergence, which leads directly to this idea of dynamic dimensional evolution.
Dimensions aren't fixed. They evolve.
Correct. They aren't just set in stone or curled up tiny like in some string theories. They emerge and transform based on resonance conditions within the hypofractal manifold.
Manifold, like the underlying space.
Yes, the underlying multidimensional space. And our 4D universe is just one configuration, one stable resonance pattern emerging from all these interacting layers. And crucially, this isn't just a Big Bang thing. It's ongoing, continuous emergence.
Okay. That is a radical departure. If dimensions are dynamic, how does BET reinterpret big cosmological observations, like redshift?
This is where it gets really interesting. Redshift traditionally is seen as light stretching because distant galaxies are moving away from us due to the universe's expansion.
The farther away, the faster they recede, the more stretched the light.
Right.
The cornerstone of the expanding universe model.
But BET offers a deeper explanation. It says redshift is directly tied to the hyperfractal dynamics of space-time itself. It's linked to the ongoing process of dimensional emergence.
So it's not just that galaxies are moving away.
It's more fundamental. It's space-time itself evolving, changing its properties as dimensions emerge, and this evolution influences the light traveling through it. The light's properties shift because the medium it's traveling through is fundamentally changing, growing more complex.
So the expansion we measure is an emergent property of this deeper dimensional evolution.
Precisely. It's not just things flying apart in a static background. The background itself is dynamically evolving, and that manifests as redshift. It's a much richer picture.
Wow, okay. What about the cosmic microwave background, the CMBR? That's usually called the afterglow of the Big Bang.
The baby picture of the universe, yeah. Usually seen as leftover heat from when the universe cooled enough for light to travel freely about 380,000 years after the Big Bang.
And the little temperature fluctuations in it are seen as seeds of galaxies, right? Tiny quantum fluctuations from the very beginning.
That's the standard model interpretation, a static snapshot, essentially a fossil from the dawn of time.
Okay. How does BB reinterpret this fossil?
It sees the CMBR not as static, but as an active imprint of the hyperfractal universe. This is a key difference. Those small fluctuations aren't just relics of the early universe, frozen in time.
What then?
They reflect the ongoing resonance patterns within the fractal layers of space-time. They're echoes of the universe's current dynamic resonance structure.
Wait, ongoing. So the CMBR isn't static. It should be changing subtly over time.
Exactly. As the universe's fractal structure continues to evolve, these resonance patterns shift. And that should lead to tiny but potentially measurable changes in the CMBR over cosmological timescales.
So instead of a static baby picture, it's more like a live feed, a constantly updating map of the universe's resonance structure.
That's a fantastic analogy. A live feed showing us the subtle shifts in the fabric of reality itself as it grows in complexity. It could reveal dynamics of dark energy or higher dimensions in a way a static picture never could.
So its uniformity shows the overall coherence.
Yes, the coherence of the whole fractal structure.
And the fluctuations show the dynamic resonances within it. A living echo.
Precisely, not a frozen one.
Okay, my mind is officially bent. If BET rethinks cosmology, what about the fundamental forces and particles? Gravity, mass, the whole shebang.
Well, it offers a fractal gravity model. This aims to provide a single coherent theory explaining how gravity, mass, and inertia emerge
Altogether, how?
through the continuous interaction between hypergravity and quantum fields.
Hypergravity again. Explain that one more time, not just more gravity.
Right, not stronger gravity in the usual sense. It's the idea that the gravity we experience in 4D originates from a more fundamental gravitational interaction happening across all the higher dimensions of the hyperfractal manifold.
A deeper, multidimensional gravity.
Exactly. And it's proposed to be consistent across all scales, from particles to galaxies, because it's tied to this fundamental structure.
And you said mass emerges from this. That still blows my mind.
Yeah.
Mass isn't built in.
Not according to HHHCR. Mass isn't intrinsic. It emerges from the coherence of a particle's fractal interactions with this hypergravity field.
Okay, coherence again. How strongly a particle syncs up with this field determines its mass.
You've got it. Think of a particle constantly interacting with this dynamic, higher dimensional spacetime. The more coherently it interacts, the more strongly it resonates with the hypergravity field, the more massive it appears to us.
Which could explain why gravity seems so weak compared to other forces at small scales.
That's one of the potential explanations, yes. If mass itself is an emergent property arising from this interaction, it's not a fundamental charge like electric charge. Its gravitational effect is secondary.
Okay. And relativistic effects, like time slowing down, mass increasing near light speed. How does that fit?
It also ties back to coherence. As an object accelerates, its internal coherence, its synchronization with the underlying hyperfractal spacetime structure, gets disturbed or altered.
Like pushing a finely tuned instrument too hard, its resonance changes.
Good analogy. This shift in its coherent interaction with hypergravity manifests as the time dilation and mass increase we observe via relativity. It's adjusting its connection to the deeper fabric. It's sometimes called frame drag, decoupling. Its internal rhythm slightly detaches from the background.
Everything is interconnected? What about quantum time and space themselves? Are they emergent too?
Profoundly, yes. In HHHCR, they aren't separate things. They're unified features of the hyperfractal structure. They emerge together, linked through these fractal processes and resonance conditions.
Not space and time, but space-time emerging as one unified thing.
Exactly. This unified view, driven by the resonance between hypergravity and quantum fields, is what ensures the universe remains stable and coherent across all scales. So this simplifies things, potentially.
Okay, this unification idea, does it extend to gravity and electromagnetism? That's the big one, right? The theory of everything.
It's definitely a major goal. And yes, Beat proposes that both forces emerge from the same underlying hyperdimensional structure.
From the same source.
Yes. How they manifest in our 4D world is then modulated by the coherence of their interaction with the fractal layers of spacetime.
So they should interact in new ways we haven't seen.
The theory predicts exactly that. For instance, near extremely strong gravitational fields, like black holes, the intense hypergravity field could cause specific frequency shifts or polarization changes in electromagnetic waves passing nearby.
Detectable effects, things we could actually look for.
Potentially, yes. New observable effects in high-energy astrophysics. That would be a huge piece of evidence. It's a definite step towards that holy grail of unifying all forces.
Which implies there might be particles associated with this deeper structure, particles beyond our current standard model.
Absolutely. A theory like this isn't just about explaining what we know. Its real power lies in predicting the unknown. Which brings us to part 2, the hyperfractal particle set, or HHPS.
A whole new set of particles based on this framework.
Okay.
Where do we start?
We start with something called hypersymmetry.
Hypersymmetry.
Right.
Like supersymmetry, but on steroids.
Huh. You could say that. It's described as the fundamental invariant symmetry structure of the entire universe, existing in the higher dimensional hyperspace. It's the ultimate source, the master blueprint from which all other known symmetries emerge.
All the symmetries we see in the standard model forces,
Mm-hmm.
they come from this deeper hypersymmetry.
That's the idea, like shadows cast by a higher dimensional object.
Mm-hmm.
As dimensions effectively compactify or reduce down to our 4D spacetime, this overarching hypersymmetry projects onto the specific symmetries we observe, the gauge groups like U1, SU2, SU3, that govern electromagnetism, the weak force, and the strong force.
And this automatically unifies conservation laws too.
Yes, because Noether's theorem, which links symmetries to conserved quantities like energy, momentum, charge, it applies to this fundamental hypersymmetry. So conservation laws are unified naturally. Crucially, this hypersymmetry provides a natural bridge between quantum mechanics and general relativity.
The bridge everyone's been looking for. How? What's the key insight?
The insight is that quantum fields and spacetime curvature aren't separate things governed by separate rules. They are both emergent aspects of this same underlying hypersymmetric structure. They're different manifestations of the same deep reality governed by the same invariant principles. Hypersymmetry provides the mathematical language to describe their connection.
Okay, that is ambitious. So if hypersymmetry is the source, how does the HHPS framework explain the particles we do know, and what new ones does it predict?
Right, the HHPS framework proposes that all particle properties, mass, charge, how strongly they interact, are outcomes of specific resonance interactions within this hyperfractal structure.
Even familiar particles like electrons, quarks, photons.
Yes, they all emerge from specific resonance conditions between our 4D quantum fields and the higher dimensional hyperfractal fields.
So a quark's mass isn't just some number, it's its resonance frequency, its coupling strength.
Exactly. Its mass depends on its resonance frequency and how strongly it couples across dimensions. Gluons, the force carriers of the strong force, are massless, but their interaction strength, the strong coupling constant, also depends on these resonance conditions.
And neutrinos, they're tiny masses and weird oscillations.
Explained by weak resonance coupling with the Higgs field and these higher dimensional fields. And their oscillations, their ability to change flavor, is linked to coherence fluctuations, slight instabilities in their resonance. The framework even naturally predicts sterile neutrinos, which don't interact via the weak force at all.
Which are a big candidate for dark matter.
They certainly are. But HHPS predicts other, perhaps even more compelling, new particles.
Okay, lay them on us. What's lurking in the hyperfractal zoo?
Well, one exciting prediction is axion-like particles, or ALPs. These would be extremely light, almost massless, and interact incredibly weakly with normal matter.
Making them hard to find, but potentially explaining dark matter?
Precisely. If they exist in large numbers, as the theory suggests, they're a strong candidate for cold dark matter. They wouldn't emit light, but their collective gravity would shape galaxies and large-scale structures. Their subtle, non-gravitational interactions might also influence cosmic voids.
Okay, ALPs for dark matter? What about dark energy? That accelerating expansion?
For that, the theory proposes hypergravitons. These would mediate a higher dimensional gravitational force, the hypergravity we talked about.
And these could be dark energy. How?
Instead of a constant energy density like Einstein's cosmological constant, hypergravitons provide a dynamic mechanism. Their interactions across dimensions could influence the expansion rate of our 4D universe. And excitingly, while they interact weakly, they might leave detectable imprints in gravitational wave data.
We could see their signature in ripples from merging black holes.
That's the hope. A specific wobble or characteristic in the waveform detected by LIGO or future observatories could be the signal of hypergravitons, potentially solving the dark energy mystery.
Wow. Any other new players?
Yes. There are dark photons, which are like regular photons but would mediate a force interacting only with dark matter particles, another window into the dark sector.
A way for dark matter to interact with itself, maybe.
Potentially. Then we have hyperfermions. These are also prime dark matter candidates, stable, weakly interacting particles arising from the higher dimensions. They might also play roles in extreme astrophysical events, like near black holes or in supernovae.
Okay. And you mentioned resonant gravitons. How are they different from hypergravitons?
Resonant gravitons are thought to mediate gravity specifically at certain resonance frequencies. They could cause subtle gravitational effects beyond what standard GR predicts, perhaps modifying gravitational wave signatures in specific ways, or influencing structure formation differently. It adds another layer of richness to gravity.
So many potential new particles tied to dark matter, dark energy, and gravity itself. And a particle's stability, why some live forever and others vanish instantly, that's also resonance.
Absolutely. Stability is a function of the coherence of their resonance. Particles with strong, stable coherence, like electrons, photons, protons, they last.
Locked into the structure firmly.
Right. Those with weaker or less stable resonance, like heavy quarks or W and Z bosons, decay quickly as their coherence breaks down.
This is huge for experimentalists, right? Concrete targets for the LHC, dark matter detectors, gravitational waves observatories.
Exactly. It moves beyond just explaining things. It makes specific, testable predictions. Finding any of these would be revolutionary.
Okay, now for some really deep cuts. Hyperspinors and hyperchirality. They sound intense. What are they?
Hyperspinors are essentially quantum entities that describe particles' intrinsic angular momentum or spin, but in the context of these higher dimensions. Think of them as fundamental descriptors of particles within the full hyperspace.
So like regular spin, but operating in more dimensions.
Kind of. They're central to a process called spontaneous symmetry breaking. This is how the universe, starting from a state of very high unified symmetry, governed by hypersymmetry, transitions into the lower symmetry state we see today, with distinct forces.
Can you give that symmetry breaking analogy again? The ball on the table.
Sure. Imagine a perfectly round table, perfectly symmetrical. Place a ball right in the center, perfectly balanced. High symmetry. Now, nudge the table slightly. The ball rolls off center and settles somewhere specific.
It picked a direction. The original symmetry is broken.
Exactly. Spontaneously broken. Hyperspinors are the quantum entities that, according to HHCR, drive this process in the early universe, guiding the breakdown of large unified symmetries into the specific SU3, SU2, XU1 symmetries of the standard model. They do this by aligning with specific resonance frequencies and coherence conditions.
So they choose which symmetries remain, and they're involved in giving particles mass too.
Yes, they play a key role in mass generation, working with the Higgs field. They determine which fundamental particles, fermions, acquire mass and how phenomena like chiral symmetry breaking occur.
Okay, hyperspinors are like the universe's symmetry sculptors. What about hyperchirality? Chirality is handedness, right?
Yes, in 4D physics, chirality refers to the left-handedness or right-handedness of particles, especially important in the weak force. Hyperchirality extends this concept into the higher dimensions of the HHCR framework.
Making handedness a higher dimensional property. What does that do?
Its crucial role is in maintaining coherent quantum states across dimensions. Particles with aligned hyperchiral states are predicted to maintain their quantum coherence much more effectively as they interact with these higher dimensional fields.
So they stay quantum for longer, less susceptible to decoherence.
Exactly. This stability, this prolonged coherence, is suggested to be absolutely essential for enabling technologies like practical FTL travel or advanced quantum communication. You need that coherence to persist across dimensional transitions.
FTL and quantum communication depend on this higher dimensional handedness maintaining coherence.
Wow. It's a key enabling factor in the theory. Conversely, misaligned hyperchiral states could lead to faster decoherence. This might even explain some weirdness we see with dark matter. Perhaps anomalies in galaxy rotation or cosmic voids arise from dark matter particles having misaligned hyperchirality, causing them to interact differently due to decoherence effects.
So it could even offer new ways to detect dark matter by looking for these coherence effects.
Potentially, yes. Targeting quantum coherence effects rather than just mass or direct particle hits.
It all ties together. Hyperspinors break symmetries, hyperchirality maintains coherence across dimensions, and hypergravity provides the unified field.
They are deeply integrated. Hyperchirality affects symmetry and coherence, hyperspinors transmit the interactions, hypergravity provides the stage. It's a unified picture aiming to connect quantum gravity, forces, and maybe even technology.
Which brings us perfectly to part 3, unleashing revolutionary technologies. Let's start with the holy grail of energy. Zero-point energy extraction, ZPE, tapping the vacuum itself.
That's the idea. Quantum mechanics tells us that empty space, the quantum vacuum, is actually buzzing with energy fluctuations. Virtual particles popping in and out of existence constantly.
Usually canceling out, though, right?
Yeah.
Making it impossible to grab that energy.
Mostly, yes, it's chaotic. But HHCR suggests that at the most fundamental level, these fluctuations aren't entirely random. They can exhibit coherence. They can align, resonate, form an underlying coherent structure within the chaos.
Hidden order in the vacuum noise.
Exactly. And a ZPE generator, based on this framework, would use hyperdimensional resonance to tap into that hidden order. It's like tuning a radio to pick up a specific station amidst all the static.
So you're not creating energy, just harvesting what's already there,
Yeah.
but in a coherent form.
Precisely. By accessing fluctuations that are in phase, synchronized with the dipole hyperdimensional structure, you can harness coherent waves of vacuum energy and convert them into usable power. Importantly, this doesn't violate conservation laws. You're tapping into the vacuum's immense energy reservoir like a dam taps into water's potential energy.
Okay, how does the actual device work? What's inside?
Several key parts. Coherence amplification circuitry selectively boosts those synchronized fluctuations. Resonance modulators dynamically fine-tune the device's resonance field in real time to stay locked onto the vacuum's coherent frequencies. Energy extraction chambers convert that captured coherent energy into usable power, like electricity.
And you mentioned special materials.
Yes, crucial components are the coherence capture matrices. These would likely use advanced superconducting materials and intricately designed metamaterial energy channels to absorb and funnel these coherent fluctuations with near-zero loss. Maximum efficiency capture.
Limitless, clean energy. The applications are staggering. Homes, cities.
Absolutely. Limitless, clean energy powering everything, replacing fossil fuels entirely. We could even have wireless ZPE grids, using resonant coupling to transmit power short to medium distances without wires. Think remote areas, easier infrastructure.
Space travel.
Self-sustaining space missions. Spacecraft could generate their own power indefinitely from the vacuum. Deep space exploration becomes truly feasible. Plus, the tech is designed for scalability modular units networked together. And naturally, high-capacity storage would be needed for larger installations.
Mind-blowing. Okay, if ZPE cracks energy, what about cracking the speed of light, faster than light travel? Physics usually says, no way, causality violation.
Right, the grandfather paradox affects preceding causes. It seems impossible in standard relativity, but HHCR offers a potential loophole. It hinges on maintaining quantum coherence at relativistic speeds and negating incoherence effects.
Coherence again. How does staying coherent let you beat light speed?
The idea is to keep the traveling object or field in resonance with the hypersymmetric structure of spacetime. If you can do that, you might avoid the relativistic effects, infinite mass increase, time stopping that normally prevent reaching or exceeding light speed in our 4D perception.
So how do you do that? What are the FTL mechanisms?
Several concepts work together. First, coherent resonance fields, CRFs. These are engineered quantum fields that stay perfectly coherent with the underlying fractal layers of spacetime, even at FTL speeds. They effectively decouple the ship from the normal 4D spacetime grid.
You're not fighting spacetime, you're flowing with its deeper structure.
Something like that. Second, these CRFs could enable hyperspace gateways or tunneling. You're not plowing through 4D space, you're taking a shortcut through higher dimensional resonant corridors in hyperspace.
Wormholes, but based on resonance.
A related concept, perhaps. Third, these coherent fields would experience reduced inertia. Less resistance from the spacetime fabric means reaching extreme velocities requires much less energy than classical physics would predict.
Okay, less resistance, shortcuts through hyperspace. But what about causality? How do you avoid paradoxes?
This is critical. The framework introduces hypercausality. It's a higher dimensional causal structure that ensures the temporal ordering of events remains intact, even for FTL travel. Events in hyperspace map back onto 4D spacetime in a consistent way, preventing causal loops. No going back to meet your own grandpa before you met your grandma.
Phew. Okay. And this leads to an advanced warp drive, better than the Alcubierre concept.
Yes, it aims to overcome the Alcubierre drive's hurdles, the insane energy needs, the requirement for exotic negative energy, the instability.
Oh, what makes it different?
Hypergravity contributions are key. Instead of needing negative energy, this drive uses hypergravity to precisely modulate the warp bubble, controlling the spacetime compression and expansion needed for propulsion. It reshapes the higher dimensional geometry directly.
And powered by ZPE. Presumably?
Absolutely. The ZPE generator feeds coherence energy into the bubble, making it stable and highly efficient.
Can you give us some numbers? How fast? How much energy?
Okay, for example, traveling at 100 times light speed, 100C. A 100 light-year journey would take about 1 year ship time, the energy needed. Around 20.81 trillion joules.
Which sounds like a lot, but compared to, say, global energy use.
It's significant but potentially achievable, especially with ZPE. For a 1,000 light-year trip at 100 C, it's about 10 years ship time, needing roughly 53.62 trillion joules. The important thing is energy scales better than linearly. It increases at a diminishing rate with distance because the bubble is stable. Time taken is just distance divided by warp speed.
And you wouldn't get squashed by the acceleration.
That's where inertial dampening comes in. The drive itself manipulates local spacetime inside the bubble to counteract inertia, protecting the crew during maneuvers.
Interstellar travel becomes plausible? Okay, down to earth again. Anti-gravity. Levitating cars. How?
Again, it's not brute force. It relies on the hypergravity coherence coupling effect to reverse gravitational interaction.
Reverse gravity, not just cancel it.
Yes. By tuning specific resonance fields, the system can decouple the gravitational mass from the quantum field mass of an object. It effectively inverts the local gravitational interaction for that object, making it repel space-time instead of being attracted.
Turning gravity wells into gravity hills, locally.
That's a great visual, exactly. The core component is the coherence engine, generating and fine-tuning this resonance field. It needs incredibly precise adaptive frequency modulation and phase synchronization to hit that perfect 180-degree phase shift for gravitational inversion. Safety systems, feedback loops, predictive algorithms are essential, of course.
The applications seem almost limitless. Spacecraft propulsion.
Near instantaneous movement within a solar system, perhaps, but also personal transport, hovering cars, flying vehicles, levitating trains, maybe even wearable devices for personal levitation.
Seriously, like a sci-fi jetpack, but silent and based on resonance.
That's the implication. Industrially, imagine manipulating massive objects effortlessly in construction or mining, lifting bridges, moving buildings.
And this isn't using negative energy either.
Correct. It looks like negative energy or negative mass effects, but the theory says it's the functional outcome of manipulating space-time geometry via higher dimensional fields. You're using resonance to actively reshape local space-time curvature without needing impossible exotic matter.
Okay, energy, travel, gravity. What about computing? Can HHHCR revolutionize that too? Quantum computing's big hurdle is decoherence.
It absolutely aims to. This leads to concepts like quantum gravitational computing and, even more significantly, coheraputers.
Quantum gravitational computers.
Yeah.
What's the idea there?
QGCs would encode quantum information, qubits, directly within gravitational fields, making computations sensitive to space-time curvature itself. They'd be specialized for solving problems in fundamental physics, field theory, cosmology.
Interesting. But coheraputers sound like the real game changer for general quantum computing.
I think so. They integrate standard quantum coherence with this deeper coupling coherence the stable coherence particles can have with the underlying hypergravity field and hyperfractal structure.
And that's the key to fighting decoherence.
Yes. Coupling coherence fundamentally stabilizes quantum systems. It anchors the fragile qubit states to the robust, coherent fabric of reality. The main benefit is extended coherence times. Qubits could maintain their quantum state for much, much longer.
Meaning fewer errors, more complex calculations possible.
Exactly. Reduced error rates because phase coherence is inherently maintained. Enhanced computational power because you can use these coherent resonance fields to manipulate quantum states more directly and powerfully. And likely much higher energy efficiency, as you don't need brute force methods like extreme cooling just to fight decoherence.
Room temperature stable quantum computers suddenly seem possible. That's huge. And hypercausal computing, what does that unlock?
That leverages the hypercausality framework, the one ensuring no paradoxes in FTL. Applied to computing, it allows for high-speed computation orders of magnitude faster than anything now. Real-time simulation of incredibly complex systems, climate, galaxies, genomics.
And better predictions.
Predictive modeling with unprecedented accuracy by tapping into this extended causal structure. Plus, quantum encryption based on hypercausal interactions of entangled particles could create fundamentally unbreakable communication channels.
It's a complete paradigm shift for computation, AI, material science, everything.
A truly transformative leap forward.
Speaking of materials science, can we use this framework to design entirely new materials with impossible properties?
That's the promise of hyperfractal materials, designing materials from the ground up based on HHHCR principles of resonance and coherence.
What kind of properties are we talking about? Self-healing metal?
That and more. Self-healing and adaptive materials that can adjust their own structure, stiffness, or repair damage at the molecular level. Think self-repairing spacecraft hulls or medical implants that perfectly integrate and adapt within the body.
Materials that can survive anything.
Extreme condition durability. Materials inherently stable under intense heat, radiation, pressure, perfect for fusion reactors, deep space probes, planetary exploration.
And energy applications. Superconductors.
Absolutely. Advanced thermal insulation that doesn't just block heat, but actively redirects it. Maybe storing it in higher dimensional energy reservoirs, revolutionary for batteries or thermal management. Hyperfractal conductors offering true lossless energy transmission far beyond current superconductors.
And you mentioned room temperature coherence, materials exhibiting that.
Coherent-enhanced materials, yes, the potential holy grail. Materials exhibiting robust superconductivity, superfluidity, or quantum coherence at room temperature. That alone changes everything for quantum tech.
Plus materials tuned to specific frequencies.
Resonance-driven materials, designed to interact perfectly with specific EM frequencies for ultra-efficient energy harvesting, wireless power, or perfect electromagnetic shielding. And the framework even suggests the theoretical possibility of engineering exotic materials, potentially including negative mass materials derived from manipulating hyperdimensional space.
Materials that fall up? Wow. Okay, this is all incredible, almost overwhelming. But how do we get there? What's the path forward? The challenges must be immense.
They are. Which brings us to part 4, the path forward. The first major hurdle is advancing the theoretical foundations.
Making sure the math holds up, right?
Exactly. The ultimate goal is that full unification of quantum mechanics and general relativity. The theory needs to be mathematically rigorous, internally consistent. It has to properly address tough issues like renormalization, how to handle infinities that pop up in quantum calculations.
And it needs to connect back to the physics we already know works.
Crucially, yes. It must clearly show how the higher dimensional HHHCR theory reduces down to standard quantum mechanics and general relativity in the appropriate energy regimes or scales. It can't just be separate. It has to encompass known physics. We need precise definitions, like for the coherence operator, with detailed derivations and proofs.
And it needs to predict things we can actually test.
That's the absolute linchpin for scientific acceptance. It must make concrete predictions, new particles, forces, effects that are experimentally testable. Otherwise, it's just a fascinating mathematical structure.
Which leads straight to experimental validation. How do we prove any of this? What's the first, maybe easiest test?
The sources point to one potentially accessible experiment, the coherence operator experiment.
Okay, what's the goal there?
To directly test if this predicted coherence operator, ORIS, actually affects the quantum coherence of real-world quantum systems, specifically superconducting qubits.
The building blocks of current quantum computers. How would you set it up?
You'd use standard superconducting transmon qubits, couple them to microwave fields inside a cavity, and cool everything down to millikelvin temperatures, standard quantum computing hardware, essentially.
And the hypothesis?
The hypothesis is, if you tune the external microwave field to the specific resonance frequency predicted by the coherence operator, the qubit's coherence time, how long it stays quantum, should get longer, and its decoherence rate should go down.
And if the frequency is off resonance?
Then decoherence should happen faster, as usual, or maybe even accelerate. You'd measure this using standard techniques like Ramsey interferometry to track the qubit's quantum state over time.
If that works. That's direct evidence for a core HHHCR mechanism, right? With immediate implications for better quantum computers.
Exactly. It would be huge.
Right.
Direct evidence for the coherence operator, validating a key part of the theory, and potentially offering a pathway to much more stable qubits and new energy systems.
A tangible result. What other experimental avenues exist?
Oh, a whole range. We'd need high-precision gravitational detectors, maybe even at the quantum level, to look for tiny variations predicted by fractal gravity or hypergravity. Dedicated dark matter energy experiments searching for ALPs, dark photons, hypergravitons.
Using the LHC.
High-energy colliders like the LHC would search for new resonant particle states, unexpected Higgs decays, shifts in how particles scatter, or weird particle production hinting at hyperchirality.
Big conventional ways, too.
Gravitational wave observatories like LIGO Virgulisa could look for modified graviton behavior, new polarization modes, or specific signatures from resonant gravitons or hypergravitons in cosmic merger events. We could also use laboratory simulations like analog gravity systems to model some effects. And, of course, ongoing ZPE experiments trying to hit those specific resonance conditions needed for vacuum energy extraction.
A multi-pronged attack on reality.
Yeah.
But with technologies this powerful manipulating space-time, FTL, the ethical questions, are enormous. How is that addressed?
It has to be central. The framework acknowledges profound ethical and societal considerations. First up, weaponization prevention.
Yeah, creating micro black holes or gravity weapons.
Yeah.
Terrifying.
Absolutely. The proposal includes strong international treaties banning such uses, plus built-in technical safeguards and fail-safes within the technologies themselves.
What about causality? FTL and time manipulation seem inherently risky.
Causal integrity is paramount. The risk of paradoxes is real. Solutions involve strict ethical guidelines, technical limitations built into the systems, and reliance on the hypercausality framework, ensuring temporal order is always preserved. No causal loops allowed by design.
So responsible use requires careful governance.
It's non-negotiable. The power is too immense for uncontrolled deployment. Public discourse, strong regulatory frameworks, ongoing ethical oversight, all absolutely crucial.
Okay, last piece of the puzzle.
Yeah.
Making it happen. This needs colossal resources.
Mm-hmm.
How do you secure funding and partnerships for something this ambitious?
It demands massive interdisciplinary collaboration. Physicists, engineers, materials scientists, computer scientists all working together, and strategically targeting key partners.
What do you need on board?
Top research institutions like Yale Quantum Institute, UC Berkeley Space Sciences Lab for the deep expertise in lab facilities, major corporate partners IBM Quantum, Google Quantum AI for scaling, funding, commercializing computation aspects, maybe Tesla for ZPE power systems given their focus.
Hypergravitons too.
Definitely. Government agencies are critical. The DOE for energy and quantum grants, NASA for propulsion warp drives, anti-gravity and space testing. Even the DoD might be interested for strategic applications, though that needs careful ethical navigation.
So a mix of grants, corporate investment, maybe philanthropy. And you tackle it in stages.
Exactly. A broad funding strategy and a clear phase development. Phase 1 focuses on ZPZ and coheraputers proving the core concepts. Phase 2 tackles space propulsion, scaling up. Phase 3 moves towards large-scale testing and commercialization. The vision is nothing less than revolutionizing energy, computing, space travel, creating a sustainable future and unlocking the cosmos.
What an absolutely incredible deep dive. We've gone from reimagining Redshift and the CMBR as living echoes of a dynamic fractal universe,
Predicting a whole new set of fundamental particles based on resonance and coherence.
to exploring technologies that sound like pure fantasy. Limitless energy from the vacuum, faster than light travel without paradoxes, anti-gravity, computer stabilized by the universe's own coherence.
It really paints a picture of a universe far more interconnected, dynamic, and frankly, potential-filled than we usually imagine. It challenges almost everything.
It really does. It feels like the common thread through all of it is this idea of coherence. This synchronization, this resonance being the fundamental organizing principle, the key to stability, emergence, and even these potential technologies.
Coherence seems to be the secret sauce in the HHHCR recipe, yes.
So here's a final thought to leave everyone with. If coherence is that fundamental, if it's the key to unlocking space-time manipulation, ZPE, FTL, what does that imply about consciousness, about information itself?
That is the ultimate question, isn't it?
Could our own awareness, our thoughts, our reality itself also be an emergent property of some incredibly complex underlying coherence within this hyperfractal structure?
If consciousness relies on quantum processes, as some theories suggest, and those processes are stabilized and defined by this universal coherence, then yes, it implies consciousness might be deeply interwoven with the resonant fabric of the cosmos itself. Information, reality, mind, perhaps all emergent aspects of coherence.
A reality woven from resonance. That's a lot to ponder.
It certainly is.
Thank you so much for taking us through this mind-bending framework today, and thank you for joining us on this deep dive. Keep asking those big, fascinating questions.